So I've taken you through all the different application categories. I've taken you through the petroleum industry, the chemical industry, the pharmaceutical, which is huge, the environmental, the food, flavor, and fragrance. But I've taught this for 30 years, and after these 30 years, I get to meet some interesting people in what I call some miscellaneous industries, things that even catch me by surprise. And I'll share a couple of them with you. One was we had a customer from the New York Metropolitan Museum of Art. So on the very first day when we were doing introductions, I got to that person. I said, "Okay, I'm drawing a blank here. I have no applications. Tell me what you do with HPLC in the art world." And what they were doing was art restoration. So imagine you have a 400-year-old painting and it's dirty, it's got some film on it, and you want to clean off that film, but you got to analyze the film. What is it? How are you going to dissolve it? You also want to analyze the paint, but you don't want to dissolve the paint. You don't want to dissolve the canvas. So not only do we look for forgery analysis and that kind of stuff, are the paints of the right age, but this is done for art restoration and so forth. So that to me was one of those interesting applications. Another one that really caught my eye that I'd like to share, and that was we had a young lady who was specializing in mosquito pheromones. So or mosquito chemicals, and the way she introduced herself was, "I'm looking to understand why a mosquito bites a person and not another person. So a group of 4 of us are standing around, a mosquito bites me, why did it choose me? What is it looking for? What is that mosquito looking for in order to decide who to sting?" So it turns out that they're looking for chemicals, which I would call pheromones, but it turns out they're called pheromones because they're between species. So in other words, the mosquito's flying around and they smell something, it's like, "I like that smell, I'm gonna go bite that person." So this young lady had set up a device to actually measure the GC response and what the bug might actually be looking at. So the way they did it was they took, this is sound a little weird, they took the antennae off of, I think they started with a beetle. The antenna lives for several hours after that. They hooked up electrodes to it, and that antenna would essentially put out an electronic signal when it found one of these pheromones. So they took a sweat patch from a human being, hundreds of chemicals in it, they ran it on a GC. As the peaks come off one at a time, they have this little antenna sitting at the end of the GC, and when it vibrates, that would tell us, oh, that is a chemical that we are sensing. So of the hundreds of chemicals in sweat, they're actually able to go down and find the reason why mosquitoes bite people, which I thought was sort of a cute application because none of us want to be bitten by mosquitoes, but I was corrected on that. It's not cute, it's very important because mosquitoes, insects, kill more humans on this planet than humans kill humans. So this is one of the biggest source of deaths on the planet. People being bitten by mosquitoes, and chromatography is at the forefront of solving that problem. So there's lots of cool applications, one-of-a-kinds. If you have some of those, please share them with us. We've helped those people in the past. We'd love to share, help you as well. Lots of interesting things going on in the chromatography world. Stop by Axion and we'll tell you about them.